Okay, so in this first part, we are going to look at like using the binomial theorem to expand to full terms. If you have a binomial and you are being required to try and expand all of them, how do you go about it? Finding all the terms in there. Sometimes they will ask you in ascending powers of x or in descending powers of x. How do you resolve such a problem? Okay, so these set of examples are going to help you to see. So the first question that we are going to look at, as we see, it says that find the expansion of I, 1 plus 2x all to the power 4. I, 2x plus 3y all to the power 3. We want to find the expansion of these ones in ascending powers of x for all of them. How do we deal with that? Let's see. Okay, so in the question that was just shown to you, we saw that we are required to find in ascending powers of x an expansion of some binomial terms. The first of them was 1 plus 2x to the power 4. Now, so we're going to apply what we just discussed. We are saying that first, the kth term of a binomial or any term in a binomial is given by n choose r, b to the power r, a to the power n minus r. It's very important for us to also know this. Now we are saying that k refers to the number of terms that we have, which means that, as we know, the 4 is the exponent that sits atop the bracket, and therefore this binomial has 5 terms, as we saw in our previous video. It has 5 terms. So we can have k equal to 1, k equal to 2, k equal to 3, k equal to 4, and k equal to 5. Now, keep in mind that in this example, or in this particular exercise, we are saying that we want to find the binomial expand in ascending powers of x. In ascending powers of x. Now watch. When we say ascending powers of x, what we simply mean is that keep the portion that has got the x on your right, or like on the second part. That is it, on the second part. The part that has the x has to occupy your second spot. So when it is there, then when you do the expansion, you are automatically going to have it in ascending powers of x. That is just what it means. If, however, it has said that expand it or find the values of the binomial in descending powers of x, then the second part here will come there. So it wouldn't have been 1 plus 2x, but it would rather be 2x plus 1. So when you expand 2x plus 1 all to the power 4, that will give you the expansion in descending powers of x. But when it says ascending powers of x, then it means the variable has to occupy the second part in there. Hope you're okay with that. All right. So let's proceed. Now we've seen again that our terms is going to be 5. So k1, k2, k3, k4, and all that. Our b will be the whole of this, 2x. The whole of 2x will be our b. Then 1 is our a component. So we just use it and slot it in there. Like we earlier learned, this means that our r, which is always one step behind our k, our r will be 0, our r will be 1, our r will be 2, our r will be 3, and our r will be 4 in here. So let's do the expansion of all those terms and see what will result out of that. So our first term, we are going to have n, which is 4, choose 0, 2x raised to the power 0, okay, 1 to the power 4. Second term, what do we get? 4, choose 1, 2x raised to the power 1, then 1 to the power 3. 1 raised to the power 3. Then we come to our third term. What do we get for our third term? We have 4, choose 2, 2x all squared, 1 squared. Then we come to our fourth term, which has r equals 3. So we have 4, choose 3, 2x cubed. Then we have 1 to the power 1. Then our fifth term, that's the last term. Just write that one here. You're going to have 4, choose 4, 2x all to the power 4, 1 raised to the power 0. Have we got it? So that makes it very clear. So we just go ahead and now evaluate the results of the expansion. Our first term will be this. So our first term, what are we going to get for that? 4 choose 0, we know is 0. That's 2x raised to the power 0 is 1, and this is going to give you 1. So our first term is 1. What happens to our second term? A second term, 4 choose 1, we know is 4. 2x raised to the power 1 is all 2x. Then we have 1 cubed, that gives you 1. So you're going to have 4 times 2x, and that's going to give you 8x. Sure, that should not be difficult for you to see. 4 times 2, okay, 8x. Then we go to our third term. That is 4 choose 2. So our third term, what do we get for 4 choose 2? What do we get for 4 choose 2? Can you guess? Okay, so our 4 choose 2 is 6. Then 2x all squared is going to give you 4x. So this is going to give you 6 times 4x squared. And 6 times 4x squared, as we know, is going to give you 24x squared. So let's just put that there. You're going to have 24x squared completely. 24x squared. Then we come to our fourth term. So in our fourth term, what do we get? Okay, so our fourth term has got r equal to 3. So that's going to give us 4 choose 3, that is 4, times 2 cubed will give you 8. Then we have x cubed. So what happens to our fourth term? Our fourth term is going to be 4 times 8 x cubed. And what is 4 times 8? 4 times 8, we know, is going to give us 32 s cubed. All right, then we move on to our last term, which is our fifth term. What happens to the fifth term? So in our fifth term, we're going to have 4 choose 4. As you can see, 4 choose 4, which is 1, 2 to the power 4, is 16. Then x to the power 4. So we are going to have 16 x to the power 4. Okay. So our binomial, that is 1 plus 2x all to the power 4, would have its completed terms, its total terms, in the ascending powers of x being 1 plus 8x plus 24x squared plus 32x cubed plus 16x to the power 4. Hope that is clear. So you will clearly see and realize that this has produced an expansion of the binomial in ascending powers of x. The x value keeps on increasing. So that is it. In ascending powers of x, 1 plus 8x plus 24x squared plus 32x cubed plus 16x to the power 4 is all going to give you that beautiful expansion there. In the second part, the second problem, we were given the expression 2x plus 3y all cubed, and we were asked to find in ascending powers of x what it's supposed to be. And like we said in the earlier part, in the previous question, anytime you are asked to expand in ascending powers of a particular variable, that variable has to occupy the b section in the way the binomial is represented. You realize that in this problem, the 2x is here. It's like occupying the first part or the a section. Then the 3y is occupying the second part. If the binomial is in this form, following the expansion, you are not going to get the x in ascending powers in its ascending powers. So when we say ascending powers, what you can do is to quickly just turn whatever is inside the bracket such that the variable which we are interested in having ascending powers is found on the second part. So let's just do that correction here. So rather than having it as 2x plus 3y, we're going to have it as 3y plus 2x. Are you okay? So that is going to allow the expansion following that to be in ascending powers. And as we know, since the exponent that sits atop the bracket is 3, it means we're going to have 4 terms. That is why we have k1, k2, k3, and k4 being the parts that we'll be working with. So k1 signifies the first term, second term, up to the fourth term, as we already know. So let's just go ahead and try and work out these expressions. Our first term, k1. So you're going to have 3, choose 1. No, our r will be 0 here. Our r will be 1. Our r will be 2. Then our r will be 3. Don't forget, we rather have to use the values of r. So here is going to be 3, choose 0. Okay, for our first term. Then b, which is 2x raised to the power 0. Then our a, 3y raised to the power 1. So when we resolve that, what do we get? We are going to get 3y. No, this would be 3, yes. So we're going to get 3 cubed. That's going to give you 27. 27y cubed. Hope that is okay. 27y cubed. Then we come to our second term. For our second term, as we know, our second term is k equal to 2. Therefore, the r that we will use will be r equal to 1. What does that give us? We're going to have 3, choose 1. B to the power r. Therefore, this is going to give us 2x raised to the power 1. And we are going to have 3y all raised to the power 2. So what do we get? This is going to give us 3 choose 1 is 3 times 2, 6. Then 3 squared is 9. So 6 times 9 is 54 x y squared. Hope that is okay. 54 x y squared. Let's move on to our third term. So our third term, remember, k equal to 3. Therefore, our r will be 2. Our third term will give us 3 choose 2, 2x all squared, then 3y raised to the power 1. When we resolve that, what do we get? 3 choose 2 is 3. 2 squared is 4, then 3. So you have 3 times 4, 12. 12 times 3 gives you 36. And this is going to give you 36 x squared y. That's our third term. Now let's move on to our last term, which is our fourth term. Our fourth term will be 3 choose 3, 2x cubed. Then we have 3y raised to the power 0. So what does that give us? 3 choose 3 is 1. 2 cubed is 8. 8 times 3 is 24. So this is going to give you 24 x cubed. No, sorry. Let's take that out. This is 0. So raised to the power 0 is going to give you 1. Yes, you're going to get 1 there. Be careful of the exponents. Anytime you have in indices and an expression raised to the power 0 is 1. So this is just going to be left with 2 cubed, which is 8. Then 8 cubed, 8x cubed. So we're going to have 8x cubed here. So we are done with our expansion. Hence, we can say that the expansion of our expression, 3x plus 2y all cubed, is the same as 27 y cubed plus 54 x y squared plus 36 x squared y plus 8x cubed. So this is our final result for that expansion. So bear in mind, when we say ascending powers of x, make sure the variable that we are interested in having in ascending powers sits on the b portion. If it's descending powers, then it can also fill the a portion. You use the binomial theorem, as we've discussed, to just work through it and take your time with the calculations, and you would eventually come to the answers completely. So this is where we bring an end to this section of how to use the binomial to expand the basic terms, either in ascending powers of x or descending powers of x. In our subsequent video, we will look at more examples of how you can use the binomial in other algebraic forms.